Hi, my name is Bhanu and I build AI agents. I have shipped enough broken agents to know what goes wrong when you take your agents to production. And in this talk, I will introduce 8 things which will go wrong when you take your agents from low environment to production. I would be using Agno as a reference framework in this talk, but you can choose any other agents like LangGraph or Crew AI, which has similar features. And towards the end, I will introduce Logic, the open source control panel we are building on the top of Agno to manage and orchestrate your agents, which mitigate all these 8 concerns. Let's get started. Every AI developer hits the same wall. Your agent works perfectly in development environment. You demo it, people love it. But when you deploy it to production, it hallucinates. It costs 10x of what is budgeted for that agent. And when something goes wrong in production, there is no trace, there is no audit, and no way to look at what goes wrong with the agent. It's not a skill problem, it's an infrastructure problem. Prototypes don't fail because the prompt is wrong. They fail because these 8 production concerns were never addressed. Here are the 8 concerns I was referring to: non-determinism, tool calling, architectural decisions, evaluation, memory, human in loop, observability, and permissions. I'm going to walk you through each of them one by one and tell you how to solve it. By the end of this talk, you will know how to address these concerns. Let's start. LLMs are non-deterministic. They can have different outputs for different runs for the same input. In notebook, that's fine, but in production, that's a bug. Your downstream system expect a consistent schema and your test expect consistent output. Answer to this concern is structured output. You can define a pydantic model and pass it to response model. Then agent is forced to produce output in a specific schema. There is no regex, no JSON parsing. You get consistent output every single time. Next gap is tool calling in MCP. An agent without tools is just a chatbot. But tool calling in production can be really dangerous. An agent can call a wrong tool, or a tool in a loop, or a tool can call 50 APIs in a chain and burn through your agent budget. That's why if you're using Agno, these 2 lines would save you a lot when running the tools. First, tool call limit. When you define it, agent would only run certain number of tools you define in the configuration. For example, 5 in this case. And second one is show tool calls. Using this, agent would show all the tools calls in the output. This is the foundation for auditing and tracing. We will talk later. Agno gives you 50 plus built-in toolkits: search, IOs, database, APIs, and much more. But real unlock is MCP, Model Context Protocol. One line of code and you can talk to any MCP server. Your internal API, GitHub, Postgre, or any other MCP server. Gap number 3 is right architecture. The biggest AI agent mistake I see is when you choose an AI agent when you needed a workflow, and vice versa. Here is the decision tree. If the task is open-ended and require judgments like a chatbot answering the customer question, use an agent. But if it's a repeatable pipeline like extract, transform, and load, use the workflow. And if you need multiple specialists collaborating, use the team. In this example, we need to do research, analysis, and writing. If we jam all these things into a single agent, that's the anti-pattern, which is prone to failure in the production. That's why the right topography for this problem is teams. We are using coordinate mode of teams in this problem, where a leader delegates the specific task to specialist agent. Look at the output on the right side. You can see which task was given to which specialist, what did they produce, and how leader combined all these output to produce the final output. Every step is auditable. Let's go to gap number 4. The single biggest gap between prototype and production is evaluation. Most of the teams are shipping AI agents without automated testing. Think about it. You would not ship any web app without a unit test. But you are shipping an AI agent which take the decisions, call customers, make many API calls without automated testing. That's why evaluation is most crucial. Agno gives you 4 evaluation dimensions. Let's go through these one by one. First eval is accuracy. Did the agent get the right answer? You can configure the accuracy eval by providing agent reference, input, and expected output. And then evaluation present the evaluation score and the reasoning of the evaluation score. Second eval is reliability. Did the agent call the right tool in the right sequence? This becomes critical for the agents with the side effect. Did the agent call the search API before producing the report? You can see on the right side, the evals are executed and the result is presented. Each eval produces the score and the reasoning of the score. Next important eval is performance, latency, and memory footprint. Is your agent fast enough to be used in real-time scenarios? And the last and most important is agent as judge. It is similar to LLM as judge, where you provide the criteria. For example, is the response factual, well structured, and cite sources? And an LLM judge the response from 1 to 10 depending upon that criteria. On the right side, you can see the execution of these two evals and how they score and provide the reasoning. One of the biggest patterns which separate toy agent to the production agent is persistent memory. On the left side, there is a self-learning agent configured. Agno stores memories per use in the database. Postgre, SQLite, whatever you're running. By setting enable agentic memory to true and providing a memory manager, an agent remembers user preferences, past decisions, and context, not just within a single session, but across sessions, across days, across weeks. And the agent automatically extracts and stores things it learned about the user. That means agents get better as you use it. On the right hand side, we test the 3 turns on that agent. In the first turn, I provided my name and that I prefer the Python programming language. In the second turn, I check whether it remembers this information. And in the third turn, I ask for a framework recommendation for application building. Let's move on to the next slide to see the output. You can see the agent remembers my preference and recommended the frameworks accordingly. The next 3 gaps are operational. That's where the most teams get stuck because these require real infrastructure. The first is tracing. Each agent should produce which LLM was called, which tools were invoked, and which sub agents were executed, how long each step took, and how many tokens were consumed. Without this, debugging in production is flying blind. Agno uses open telemetry. Every run is a trace with the span. You can inspect, export, and alert on. The second one is cost. LLM calls cost money. In production, you need to know cost per agent, per tenant, and per model. For example, consider an example where an analyst agent costs $1. If you don't know via tracing that it spawned 3 agents, you will never know where the cost happened. Without this visibility, an runaway agent can call tools and create agents and cost hundreds of dollars in a minute. And the third one is auditing. Every action taken by agent should be logged with a timestamp. Along with that, who triggered the agent, which tools agent called, how a tool was called as an input, what did it produced. Everything should be logged. In healthcare, finance, and legal, it's not an option, it's a legal requirement. Building all these from scratch take months. That's why we built Logic, which have all these features built in. Let's explore that. This is Logic, the open source control plane for AI agents. Think of it as a Kubernetes but for agents. Agents are configuration, Agno is an engine, and Logic is a control plane. Here is the agent builder. You start with basic information and select your model. Then you configure your tools using built-in options or custom integrations like HTTP or MCP tools. You can attach organizational or application specific knowledge, enable agentic memory and learnings. You can also set up advanced reasoning and guardrails. You can also specify the structured output, configure automated evaluation, and once saved, your agent is ready to deploy. Let's test this agent. From the agent screen, you can start conversation. As the agent execute, it automatically decide which tool to use. Because we enable the memory, it remembered the user context. For example, it remembers that I work at Maersk and I am a senior AI engineer, and it tailored the response according to me. And if the agent determined that it figured out the new information about the user or the context, because we have enabled the agentic memory, it will save the information in the memory store. But this is not just a chat UI. Behind the scene, complete observability is available. You can see exactly which tools were executed, how many tokens were consumed, and what was the total cost. You can inspect the memories which were retrieved. You can also look at the waterfall of traces to see how much time was spent on each step. And if you have enabled the evaluation, you can also look at that. Beyond the individual agent, the platform offers the full management of your organization and the tenant. There is a complete documentation of each and every feature. And when you need to scale up, you can use a visual builder to create the workflows. You can configure agents and make them run in sequential or parallel mode. Considering the time limitation, it was just a quick walkthrough of the Logic, but please check it out for all the features of this platform. Let's revisit what we learned in this session. On the left hand side, there are the 8 gaps we started with in this session. And on the right side are the solution for each gap. Structured output for determinism, eval suits in CI for the regression testing, MCP for universal tool integration, teams for multi-agent orchestration, memory for self-learning, human in loop for safety, full tracing and cost monitoring for the operation, and a control plane to tie it all together. That's the playbook, and that's how you escape the prototype trap. If you find it useful, I have 2 asks. First, try Logic. It's fully open source and self-hosted platform. You can have it running in 5 minutes using Docker Compose. Link for the repo are on the screen on the right side. You can scan the QR code for the link. And second, if you like it, please start the repo. It helps other developers to discover the repo, and it keeps us motivated to build in the open. I would love to connect. Please find me on the LinkedIn using the QR code on the left hand side. I'm happy to talk about agents, production patterns, or anything we discussed today. Thanks for watching. Now ship some agents. Agents that don't just work on your machine. Thank you.